we're going to get into section 3 and section 3.1 exponential functions and their graphs. And some things with exponential functions. Exponential functions, logarithmic functions, and trigonometric functions are all forms of what we call transcendental functions. So like I said, exponential, which we're going to talk about now, logarithmic, which we're going to get into in chapter 3 as well, and something a little further down the road, but trigonometric are all forms of transcendental functions. Up until this point, we've basically covered algebraic functions. So this takes it to another level that we haven't dealt with in this course yet. Now, one thing that you're going to see is a general form. It's going to look something like this. F of x equals a to the x power. Now, again, some real basic situations or vocabulary here. Obviously, that's our exponent. Dealt with that before. The value at the bottom here, that's known as our base. And we just read this as the exponential function of x with base a. All right, now a couple things that we need to set up here for this one. When we go through this, the ones that we're going to consider right now are positive bases. We're also going to do a situation where a is not equal to 1, and our x value is any real number. So the big difference from what we've been doing is usually we've had the variable in the base and the exponent was a constant. Now our base is going to become a constant and our exponent is going to become our variable as we move into these exponential functions. Now why don't we consider 1? Well, if we look at f of 1, that would actually be giving us, oops, I shouldn't say f of 1, f of x equals a to the first power, or a to the x power. That's going to tell me that if I put 1 for any power, I'm always going to get 1 for a solution, which is not exponential, that's a constant. So that's why we're not going to consider x equals 1. As far as what we can do with this, we'll start with the very basic, and we'll just start with evaluating. And again, very crudely, evaluating exponential functions is basically just saying plug and solve. Simple as that. So they might start us out with exponential function f of x equals 2 to the x power, and you might just be asked to evaluate for a few values. So they might have us do x equals something simple like x equals 2. They might have us do x equals a fraction, 3/2, and they could have us go with decimals, x equals, let's go negative this time, negative 3.1. Alright, so like we said, plug and solve. This just means that f of 2 would equal 2 to the second power. So pretty simple on that one. 2 squared equals 4. Alright, f of 3/2 just means like it said before, 2 raised to the 3/2 power. So on this one, if you remember, the 1/2 power is the square root, and then we would raise that to the third power. This one, oops, I should say f of 3/2. If we go to calculator and get an estimate on this one, it's going to be approximately 0.1166291. Probably almost exactly as you would have guessed. Now, if we plug this into the calculator, because the calculators are following order of operations, you want to put that exponent in parentheses so you don't miss out on doing the order the right way. Otherwise, most of the calculators will treat it as 2 to the third, which is 8, and then it'll do 8 divided by 2, which is 4. Obviously a long ways off from this. So same thing here, we would just plug in negative 3.1 in place of x and do 2 raised to the negative 3.1 power. So again, this one, we'll let the calculator do the work. Turns out to be approximately 0.4647580. So again, big things on this, plug and solve. Doesn't take a genius to figure that part out. The other part is on the calculator, fractions. Put them in parentheses on the calculator. Big thing. Otherwise you're going to get a solution, but it's not going to be the solution that you're looking for.